All right, mathematicians, we are preparing for the ACT test. So we're trying to refresh our memory on things. Hopefully a lot of this will come back to you. In fact, if you know what to do, pause the video, work through these, and then check your answers. All right, so to get rid of these parentheses, I'm going to distribute this 3. So 3 times x is 3x. 3 times 4 gives us 12. They're not like terms, you can't combine them. That's as far as we can go with it. Number 2, we're going to distribute this negative 7. Negative 7 times 3x gives us negative 21x. Negative 7 times negative 4y gives us positive 28y. Again, they're not like terms, you can't combine them. Like terms have to have the same variable and the same exponents if you see any exponents. Number 3, we're subtracting these two polynomials, so we want to look for the ones that are like terms. So we have x squared minus 3x squared. That gives us negative 2x squared. Then we have negative y squared minus negative 7y squared. So that's going to be the same as negative y squared plus 7y squared. That gives us positive 6y squared. And then we have to subtract the 4xy. There's no like term to combine it with. The order really doesn't matter here. Typically we see the highest exponent, especially for your first variable as it comes alphabetically. Number 4, we got a binomial times a binomial, so we're going to distribute twice. We're going to multiply 2x times the x. We get 2x squared. Then we'll multiply 2x times the 6 and get 12x. We'll follow that up by distributing the negative 5. Negative 5 times x is negative 5x. And then negative 5 times 6 is negative 30. If I had more room, I would just write it left to right. But we do have some like terms we can combine here. So let's combine the 12x and the minus 5x, and we get positive 7x. Some people like to call this the FOIL method, but it's really just distributing twice. All right, this next one, we want to solve this equation. To get rid of these parentheses, we'll distribute the 3. So 3 times x gives us 3x. 3 times 4 gives us 12. Now we see what we classic two-step equation. To get rid of plus 12, we'll subtract 12 from each side of the equal sign. So we have 3x equal to negative 18. And then to get rid of multiplying by 3, divide by 3. We could check this by plugging it back in. And so we'd have 3 times, in parentheses, negative 6 plus 4 equals negative 6. So we can combine the negative 6 and negative 4 to get negative 2. And then we can multiply it by the 3 in front, and we see that it is, in fact, equal to negative 6. It checks. It works. That's particularly helpful on the ACT, where you'll have answer choices. So if you just have no idea how to solve an equation, but you have the solution, then you can try plugging it in. On a lot of problems, that will work. Now this time we have the absolute value of x minus 3 equal to 7. I'm going to take a detour real quick. Let's suppose we just had the absolute value of y equal to 7. Well, that y could be positive 7 because the absolute value of 7 is 7. Or that y could equal negative 7. So we have two solutions. We're going to do the same type of thing here. Let's take the stuff inside of the absolute value. Let's let it equal 7 because that's a possibility. Or we're going to have the second solution. We're going to say x minus 3 could equal negative 7 because the absolute value of negative 7 is 7. So that gives us two equations to solve. To get rid of plus 3 or minus 3, we'll add 3 to each side of x equal to 10. To get rid of minus 3, we'll add 3 to each side. But this time we have negative 7 plus 3, that's negative 4. So we have two solutions here for this absolute value inequality, or absolute value equation. Most absolute value equations will have two solutions. Now, can we take the absolute value of something and get a negative? Well, no, the absolute value is either 0 or it's positive. So this one's going to have no solution. There are no ways we can take the absolute value of something and get a negative. All right, this one is really just a two-step equation, but it is a little bit more complicated because we have these mixed numbers. So to get rid of minus 5 2/3, we'll add 5 2/3 to each side. Now we've got some fractions, but they don't have the same denominator. So let's get a common denominator. We can choose a common denominator of 12. 4 times 3 is 12. 1 times 3 is 3. So we could write it as 8 3/12. And then this next part, 3 times 4 is 12. So we can multiply the top by 4 and get 8. And so now that these are have common denominators, we can add the numerators to get our answer. So 8 plus 5 is 13. 3 plus 8 gives us 11, and those are twelfths, 11/12. All right, so we have 2x equal to 13 and 11/12. To get rid of multiplying by 2, we divide both sides by 2. Now, it might be helpful to go ahead and, I guess, change it to an improper fraction. 13 times 12, 2 times 3 is 6, 2 times 1 is 2. Yeah, I don't know why I wrote it up there. And then 1 times 13 is 13. Add them together, we get 156. Don't forget your place value there. So 156 plus the 11 will give us a new numerator of 167. So 167 over 12, and that's getting divided by 2 or multiplying by 1/2. So we get 167 over 24. And then I guess we can do some long division. Of course, if you have a calculator, you can do this a little bit quicker. I think it'll go in there, what, 7 times? Oop, nope, I'm just one short. All right, 6 times. 6 times 4 is 24, carrying a 2. 6 times 2 is 12, plus the 2, 14. Subtract, you get 23. So 6 and 23 24ths. So a little messy with those mixed numbers. All right, here we're told that h is -3. So we want to substitute in. We're trying to find the value of this expression based on the fact that h is -3. So we've got -3, and then in parentheses we have -3 plus 1, that's -2. -2 to the 4th power. -2 times -2 is +4, times -2 is -8, times -2 is +32. So we have -3 times 32, we get -96. That's our final answer. That's the value of that expression when h is -3. This time we're told to find the value of the expression x plus y in parentheses cubed. And then we have this equation to go with. Well, I don't know what x or y is, but I can add y to each side. They're not like terms, but it gives us this expression x plus y equal to 5. I have x plus y right there, so I can replace one with the other. So we can say it's x plus y, that's the same as 5. And 5 cubed is 5 times 5 times 5. 5 times 5 is 25 times 5, 125. This time we're told a is a real number and a cubed is 216. Well, what number to the 3rd power is 216? And you could just do some. 5 cubed is 5 times 5 times 5. We saw that earlier, 125. So that's too small. But if we try 6, 6 times 6, that's 36 times 6. Well, 6 times 6, 36, carrying a 3. 6 times 3 is 18, plus the 3, 216. So if we cube root both sides, this is the part we could use our calculator for, we get a equal to 6. Now we're going to take that 6 and substitute it in. We have 6 squared minus square root of 6 times 6. 6 squared is 36. Square root of 6 times 6, if you need to, you can multiply that. 36. The square root of 36 is 6. So we get 36 minus 6, and we get 30. So a lot of variety on expressions and equations here. This time we want to solve this. It's called a literal equation anytime we have more than one variable. We want to solve for L. So we're going to divide by WH on each side. So volume divided by WH equals L. We have L by itself. We're done. Sometimes you'll see the L on the left side. This time we have x squared equal to 100. Square root both sides. We get x equal to positive or negative 10. We could cube root here, and we'd have y equal to positive 2. So what is x times y to the 6th? Well, we actually have two solutions here. If we plug in a negative 10 for x, 2 to the 6th power, that's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So one possibility is that we'd have negative 640. Another possibility is that x could be positive 10. And so then we'd have 10 times 2 to the 6th. And so that would be positive 640. So positive or negative 640 would include both of our answers there. This time we want to solve for x. To get rid of plus 7, we'll subtract 7 from each side. When we do that, we get 35. All right, I'm pretty sure I meant this to be 43 here. Now that's going to give us 36. To get rid of squared, we'll square root. Don't forget about the positive or negative answers here. So we get positive or negative 6. All right, so hopefully these are helping you refresh your memory on lots of different expressions and equations you might have on the ACT.